we have a good model with a very high adjusted R-square of 90.962, which says that the model accounts for roughly 96% of the variation in sales. But recall that we also had one of our dummy variables for August was not significant. So what we probably should do is to rerun the model without August. And the way we're going to do that is just to delete the August column. Here I've switched over a copy of the data. I'm just going to select the August column and delete it, and everything moves over. I'm going to go to Data, Data Analysis, Regression, bring up my box, and I need to get my Y range. Go over here and get my sales. Those in, and now I need to select my X variables, which are all of the dummy variables in the period, the month. Get those all in, make sure they match. We have labels, and I'm going to put the output in P1 and just click OK. Now I'm going to zoom over here. Okay, I've expanded the regression output and change those scientific notations for the p-values into ordinary general format, and you can see that we're still significant, and all of the coefficients, intercept down here, are statistically significant. So that means the model might be better. But if we look up here on the R and R square, and I'm going to reduce the decimals there a bit, we have an adjusted R square of 0.9616. And if I recall, I want to click back here, the adjusted R square for the model with August was 0.9622. So that R is just a little bit better. R square is a little bit better than this R square. So we're better off to use this model to do our final forecasts. We're going to forecast ahead for 12 months. So I'm going to select those three so I can drag my series down to October of 13. Whoops. There's October of 13. In order to get the model, we need to copy down our dummy variables as well. So we can go back up here and select these dummy variables from November to October, copy those, and then I'm going to paste those in. So now we're set up, and all we have to do is drag down the regression equation, and we've got our values forecasted ahead for 12 months using our best fit trend and seasonality regression equation. I added those data points down here to the bottom of our data for the scatter chart, and you can see now here's our forecast ahead that has both the trend and the seasonality, and that'll give us a pretty good, the forecast should have about 96% of the variation accounted for. So that's pretty doggone good.